Let's solve problem 11. That states after school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took bus. The graph that is given here shows their journeys, and we have to find out what was the difference in miles per hour between Naomi's and Maya's average speeds. So we have to calculate their average speeds. So as we know, the formula for calculating the speed is simply distance over time. So the distance that was covered by Maya, so that was 6 miles. So I will just label it as SM for distance that was covered, or the speed Maya, that is for Maya. So D is the distance, and that is in miles, so it is 6 miles. Divide by the time, and the time that we have, that is 30 minutes. So I will just convert this 30 into the hour. So then if I simplify, I will get, sorry, it should be 30. So if I solve it, I will get 12 miles per hour. So similarly, we can calculate for Naomi. So as n, that would be then equal to the distance, that is again 6, and the time that it took, that is 10 minutes, and then we can solve it, and we will get the speed, that is 36 miles per hour. And now in order to tell the difference between their speed, we can simply subtract both speeds, and the answer then that I get, that is 24 miles per hour. So E is the answer for this problem. Move to problem 12. So where we are given a positive integer n, the factorial notation represents the product of the integers from n to 1, and an example is given here. What value of n satisfy the following equation? So this is what we have to answer. So let's solve it. We are given five factorial dot 9 factorial equal to 12 dot n factorial. So what we can do in this problem, we can expand 5 so to make it equal to 12. So let's do that. So now from here I can see that this 4 multiplied by 3 and 12, they are equal, so I can divide both sides by 12. So I can write it then 5 multiplied by 2 multiplied by 9 factorial multiplied by 12 divided by 12, and here I can do again the same thing, divide by 12. And now if I see, it cancels out, and n factorial is equal to 10 multiplied by 9 factorial, and that is equal to 10 factorial. So which gives us that n is equal to 10. From here the answer is A for this problem. So let's look at problem 13, where it says Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange. socks. After adding more purple socks, he noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add? So we can set it up like this. So let's take the ratios of the purple socks with the total socks. So the purple socks that we have 18 plus P, which are the newly added purple socks, and then the total socks that we have, they are 36 plus P, and that ratio is equal to 60 over 100. So then if we simplify, we can write it like 3 over 5. And now we can simply cross multiply and solve it. So then here is 108 plus 3b, 90 plus 5. And then we can collect the terms on like on one side of the equation. So we get then 2p equal to 18 and p will be equal to 9. So the answer is then B for this problem. Guys, let's solve problem 14 now, where we are given this bar graph, and that is about population of 20 cities, and we are also given cities here on the x-axis. So it says the average population of all the cities is indicated by the horizontal dashed line. So this dashed line, it represents the average. Which of the following is closest to the total population of all 20 cities? So what we can do, we can simply take the average and multiply by 20. That's all that we have to do in this problem. The other option could be like to take the quantity for or the population for each city and then add that up, but that's very time consuming. So let's do it in the faster way. So now if I read, I can see that each of this grid, that is 500. So, and it is 2000 here. I have 4000 up there. And then this is 4500. And this dotted line is in the center of these, like this 4500, and it is between 5000. So then it would be 4750. So to estimate the population, I can simply multiply for the total population. I can multiply 4750 with 20. And if I multiply, I get 94 and then 95. So it should be then 95,000. So the answer is then D for this problem. So let's solve problem 15, where it says suppose 15% of x equals 20% of y, but percentage of x is y. So what we are given is 15% of x equals 20% of y. So 15% of x equal to 20% of y. And we have to tell what percentage of x is y. So basically we have to rearrange this equation for and isolate y. So Let's first simplify it. So I will get 3 over 20 multiplied by x. So here I will get then 1 over 5 y. So if I multiply equation on both sides with 5, then I can isolate x. So I multiply by 5 on both sides, it cancels out, and y is equal to now 15 over 20x. Or I can also write it like this: y is equal to 3 over 4x. Since the question is asking in terms of percentage, so I will now convert this 3 over 4x into percentage by multiplying with 100 and 25. So I will have then 75x. So then the answer is 75%. So it should be C, the answer for this problem. Okay, so now let's look at problem 16. Where we are given this diagram, and it is mentioned that each of the points A, B, C, D, E, and F in the figure below represents a different digit from 1 to 6. Each of the 5 lines shown passes through some of these points. The digits along each line are added to produce 5 sums, one for each line. The total of the 5 sum is 47. What is the digit represented by B? So first we can represent the sums in terms of the alphabets which are given. So if I uh, make all of them, I get A plus B plus C. Then I can get another, that is C plus D plus E. And then similarly I can get another line, that is A plus F plus E. Similarly I will get another line, that is B plus D. And I can get another line, that is B plus F. So now I will sum them up and I get 2A plus 3B plus 2C plus 2D plus 2E's and plus 2F, and that is equal to 47. And now if I see other than B's, the rest are all alphabets, like they are appearing twice in this sum. So I can rearrange this equation like this: 2A plus 2B plus 2C plus 2D plus 2F plus B. So I just brought this B outside here, and now I can write this sum as 2 into A plus B plus C plus D plus E plus F plus B equal to 47. So we are already told that the numbers are in the range of 1 to 6, right? And they are different for all the cases. So it doesn't matter what number we assign, but if I take sum of numbers from 1 to 6, that is So if I add, I get 21. So 21 is the sum of all of these alphabets, but at this stage we don't know what is the value for any of these alphabets. However, what we know, the sum. So the sum is 21, and I can put that here. And now I have one unknown, and I can solve for that. And that unknown is b. So b is 5 then. And the answer is E. Problem 17. So where we are asked to find out factors of 2020 that have more than 3 factors. And an example is given here. So first we need to find the prime factors for 2020. So the prime factors that we have, we can find them with this method. We just write 2020 and divide it with 2. We will get this, then we divide with 2 again, we get 505, and then with 5, and then we get 101, and then if we divide with 101, I get 1. Since 101 is the prime number, I cannot do anything further. So now the prime factors that I get, they are okay. So now I need to see how many total factors are possible. So total factors I can simply calculate by taking the power of each prime factor and add 1 there, as I'm doing here. So now if I multiply these, then I will get 12. So the 12 are the total factors that are possible for this number. So now I will write all those 12 factors, and from them I will find out which factors are having factors more than 3. So if I list down the factors for 2020, the first one is definitely 1, second is 2, 4, then I have 10, 20, 101, 202, 404. Similarly, I will have 505, 1010, and 2020. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think I missed one of that. 1, 2, 4. I think 40 should be 1, 2, 4. Oh, sorry, I missed 5. Okay, 5 was one of the factors. So now the total factors that I have 12 factors. Now I have to check how many of these factors they have more than 3. So I can solve it in the opposite way as well. Like if I first see how many have 3 or less. So I would write number with factors less than 3. So for example, if I look at 1, so we know 1 only has 1 factor. So I will write then 1 as 1 factor. 2 can have 2 factors. One is 2 and the other one is 1. So 2 will have 2 factors. 4 will have 3 factors. 1, 2, and 4. So it will have 3 factors. Then 5 have 1 and 5, 2 factors. And similarly, if I see 101 also has 2 factors. So there are two factors for 101. So other than that, if we check all of the number, they will have factors greater than 3. So what we will do now, we can simply subtract 5 from 12, and then the answer will be 7. So 12 minus 5, that is equal to 7. This 5, it is coming from these numbers 1, 2, 3, 4, 5. So if you sum that up, it's 5. So 7 are then the factors of 2020 that have more than 3 factors. If you want to check, you can check. For example, if you want to check 10, so you can see that 10 has 1, 2, 5, 10. Similarly, if you check others, they have more than 3 factors. I hope it explains. Okay, so let's solve problem 18, where we are given this shape and we have to find the area of this rectangle that is inscribed in this semicircle. So some of the dimensions that we are given, they are the length of DA, so that is 16, and we are given FD equal to AE equal to 9. So we are basically given the dimensions for this and for this segment as well. And we have to tell what is the area of ABCD. So to find the area of ABCD, we need to know the length for DA, and also we need to know the length of DC or AB. So we are given DA, that is 16. However, we have to find DC. So we can find DC by making use some of the dimensions that we are given here. So if we see, we are given the total diameter of this segment, and the diameter is 16 plus 9 plus 9. So that would be 25 and then 34. And if I calculate the radius, that would become 17, and that is this. So if the radius is 17, so that means that if I create a triangle, so then this value is 17. And since this is the midpoint, so then I will have 8 from D to this point. Let's call this point O, and then we can find the length of CD. So we can apply basically the Pythagoras theorem. So with that, DC equal to 17 square minus 8 square and the square root of that. So then we would simply get 289 minus 64, and that is 225, that is equal to 15. And this length, if I write it is 15. So now I can plug this length here and I can solve it for the area, and if I multiply, I get then 240, and that is the answer for this question. Let's problem 19. That states a number is called flippy if its digits alternate between two distinct digits. For example, 2020 and 37373 are flippy, but 3883 and this one are not. Okay, so we have to find how many 5-digit flippy numbers are divisible by 15. So to solve this problem, first what we can do is make 5 spaces, one for each number. And now we can make a couple of observations based on the divisibility rules, that a number to be divisible by 15, it has to be divisible by 3 and 5. So if we recall, for a number to be divisible by 3, then the sum of all the digits should be divisible by 3. And for 5, if a number is divisible, then it should end in 0 or 5. So if I write zeros, then I can, if I write for example 0 here, so then this number will not be the possibilities, because this is basically a 4-digit number. It is not a 5-digit number. So this is not the option. So it means that we will only be having the number ending with 5. So then I can write 5, 5 and 5. So now I need to see what number I can fit in these two spaces. So if I write 0 and I sum these number up, it is 15, so that is divisible by 5. So it means that one of the answer is this. Second, I can try 1. That would not work, because if I add them up, I get 17, so that is not possible. So similarly, like if I add now a number with having 2's here, that will also not work, because it is 4. 6 will work. 3 will work, because if I add, I get 21. So this would be my second number. So similarly, I can now add the multiple of 3's. So I can then add 5, 6, 5, 6, 5. That would be the third number. And another number would be 4. So the answer for this question is then 4. That is B. Solve problem 20, where a scientist walking through a forest recorded as integers the heights of 5 trees standing in a row. He observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost when rain fell on her notebook. Her notes as shown below, with blanks indicating the missing numbers. Based on her observations, the scientist was able to reconstruct the lost data. What was the average height of the trees? So a couple of things that we need to keep in mind. The recordings were all integers that she did. So based on that, if the number 2 tree is 11, then the 1 it should be 22, and 3 is also then 22. So now we can have multiple possibilities for tree 4. One of the possibility for tree 4 is 44, or it can be 11. Based on the possibilities that we have for tree 4, the result then for tree 5 will be based on that. So now let's make the list. So what our numbers are, and then we will take their sum and take the average. So let's say we have 22 plus 11 plus 22 plus 44 plus 22. And similarly, we have 22 plus 11 plus 22. And similarly, we will have the third possibilities, that is 22 plus 11, 88 plus 44. So one of the main observations that we can make from these numbers is, in order for a number to end in 0.2, then the sum of the digits, it should be the sum of the numbers, it should be equal to 1 greater than the number divisible by 5. So all what we need to see, then the number, it should either end in 1 or it should end in 6. So let's see which number it ends in 1 or 6. So if we add the first one, we get 55 plus 44 plus 22, so we get 66 plus 55, so we get basically 121. And if you divide it with 5, you will get, your answer will end in 0.2. And then if we further solve it, we'll get 24.2. So then the answer for this problem is B.